Hi, welcome to Math Minute. My name is Adam and today we're going to be talking about implicit differentiation. So up until now we've been talking about equations where we've just differentiated x, the variable x. So now we're going to talk about what happens if we have an equation with x and y. For example, this circle, x squared plus y squared equals 25. So what this equation actually does is it implicitly defines y as several functions of x, which is really confusing. But all that says is that we're going to treat this value y, this variable y, as a function of x. So we can rewrite this equation like this. X squared plus a function of x squared equals 25. So what we're going to do is implicit differentiation, and there's a few steps that help us do this. So this right here are the steps that can help us do, that are about implicit differentiation. So the first thing we're going to do is we're going to differentiate both sides of the equation with respect to x, treating y as a function of x, just like we did down here. We're going to view this as a new function. So something you should be thinking about right now is a function inside of a function, a composite function or chain rule, which is going to be very helpful for implicit differentiation. So after that, we're going to solve the equation for y prime, which equals dy by dx. You can write it either way you want, and I'll show you here what that means. So I'll just do an example real quick. And this is that example of the equation that I already showed, the circle. So we want to find dy by dx. So what we're going to do is first, by step one, we're going to differentiate both sides with respect to x. So d by dx of x squared plus y squared equals d by dx of 25. So with the sum difference rule, we can split this into two. So we have d by dx of x squared plus d by dx of y squared, which equals 0. The derivative of a constant is 0. So this is an easy one. We're taking the derivative with respect to x of x squared. We know that that is 2x. That's the power rule that it's one of the first things we learned. Now this here, notice how we're differentiating this y squared with respect to x. But remember that y is just a function of x. So what we're going to do is chain rule. So chain rule says we have the derivative of the outer function at the inner function multiplied by the derivative of the inner function. And if you have some difficulties understanding how this breaks down to this, there's some more examples in your textbook that should help you see that. So this equals 0 still. Now this is the part where you can write this as y prime or dy by dx. We've been used to seeing y prime in some cases dy by dx. Whatever is more helpful for you is great. So in this case, now we just need to differentiate y squared with respect to y. So we have 2x plus 2y times, I'll change this to y prime now, which equals 0. So now the last step says solve for y prime, and that's all we have to do. So we have 2y times y prime equals negative 2x. Y prime equals negative 2x over 2y, so therefore y prime equals negative x over y. And that's using implicit differentiation to find the derivative, dy by dx, of x squared plus y squared equals 25. So there's a lot of ways we can do this. Your first thought of how to do this might have been to solve this equation for y and differentiate. That would have worked also. But you see, if you try that out, you'll see that that'll be a difficult derivative to solve, and this process is actually much easier. So implicit differentiation is a really helpful tool. Hopefully these steps have helpful. This example, hopefully it's been good, and we'll hope to see you next time.